Vasily, hi.
Hi, Anton.
A long time ago, we decided to make a video about computer vision in smart robotics. Let's tell our listeners a little about our startup firstly. Can you briefly describe the general idea?
Yes, I think it's worth showing a short video. Here's a robot of our first customer, which we are training. And this is a very classic case of bin picking application, which was trained and controlled by our solution. I think I should give a little bit of history to explain our approach. Smart robotics actually is a pretty special case for computer vision. And the first and the most important here is that robots interact with objects they see. And based on that, we got an idea that when you remotely control any robot, you actually do annotation at the same time. Which means that we can train robots controlling them remotely. And it's very similar to modern ML flows, when instead of annotation, we have remote control and supervision instead. Again, the whole idea is to help robots remotely remember commands, visual streams, and use all of that to train after.
I'm afraid you're speaking to general, so it's worth clarifying that what application you are talking about and what our role is here, basically where we are now.
Okay, I have to explain what we have made and for whom. So this is a cloud-based solution to which robots can be connected. And robots are becoming very simple in this case, and their brain with all retraining functionality are taking out to GPU servers. And it means that we are targeting robotic vendors or integrators who can reduce time to market seriously, focusing on very specific hardware problems in their particular applications. And speaking of applications, mainly we are speaking of cases when robotic arms interact with any object, picking, placing goods in retail, machine tending, in industrial applications, in harvesting, for example. And now we are looking at mobile robots because when one drives, he actually shows the trajectory to follow, and it's a pure annotation case as well.
Okay, and let's speak a few words about our data flow.
Yeah, sure. So what we have here in the middle is our backend located on servers. Mainly streams from robots are routed to ML processors, to the storage and operators when it is required. And each command is remembered, so it can be and it will be used to train it after. And new weights are loaded back to ML processors of each training.
Okay, and I think it's time to show the video of the training procedure.
Yes, I will comment on what's happening while it's playing. It consists of two stages, remote control and launching a training session after. As you can see here, an operator sets boundaries of an object, chooses a picking point and where to place it. The robot immediately performs the action. You can note how convenient it is in virtual reality to deal with 3D objects in 3D space. It really gives more control over the robot. However, in different applications, different client apps can be used. Of course, it's easier to have 2D UI in case of planner tasks. Usually, it is required a few hundreds of commands to launch the initial training session. One session allows us to reach 99% accuracy. With a couple of more sessions, much better results are reachable. Keeping in mind 30 seconds per one pick in this manual mode, we can estimate that it takes about 1 hour if there was no initial data at all to prepare this data. The next step is to add a data session from the examples we have shown just now. So we go to our console, choose the robot, what types of commands we'd like to see in the data session, and we can see all of them in the list. Here we pick 55 last samples. Check how these frames look. Visual context, sensor measurements, and JSON commands are stored in our cloud. And it is important here that we divide data sessions and training sessions, because it's absolutely normal to have more than one data set during one training. And this one will be called grocery 1, and we can see it in our list with all added commands in it. Heading to training sessions. Let's create one. We can balance the datasets, and in this particular example, we split it weights 50-50 between the new one and the base dataset that we created beforehand. Some parameters are set here, like learning rate, batch size, and we found ourselves in the page from which we control Apache Airflow on our GPU machine, choosing the ML pipeline we need and launching it. We can go to Tenderboard and see losses. Here everything goes well, losses are falling, and in this ML pipeline, actually 3 neural networks are chained, and Airflow helps to manage them consequently. In an hour or so, we can see how this works with the new weights. A new task based on them is chosen, and it basically works. Note that objects are packed tightly in the target bin. This is becoming possible thanks to a very precise 3D scanner we used here and boundaries estimation in ML. So the whole training procedure takes about 2 hours, and the accuracy reached here was 99.94% when a base dataset was involved. And the picking pace here is about 400 picks per hour. That corresponds to manual labor force performance or other pick-and-place automated solutions we saw on the market. So it looks good, works fast, and very reliable.
This task was bin picking, but we are not limited only by this one.
Yes, for example, it's pretty often in machine training to orient parts correctly, and this may be very tricky sometimes, but it's still possible. And we have a video of another application which was trained also using our toolset. By the way, in this time-lapse video, we had almost 2 hours of work without a stop, and it corresponds to 99.5 reliability. Actually, in some bin picking applications, we can achieve even 99.95 after a few teaching sessions. But remember, even in case of computer vision failures or collisions in robotic control, we still have a remote supervisor to resolve this issue.
Okay, thank you. It was our first video where we were talking about RemBrain, our startup, and its current state. Please comment if there is something particular to mention in our next videos, or subscribe on our LinkedIn channel. Thank you.